Hey, sixth graders. I want to make sure that you've done this Spark Your Learning, this problem on the Google slide and submitted your answer before you watch this video. So if you have not done that yet, please go back to Canvas and do that, please. Otherwise, we're going to get started. We're going to write algebraic expressions to model situations in this lesson, and our goal is that we can use variables to write algebraic expressions to represent real-world problems. And it's a little bit review, I think, some new vocabulary, but other than that, I think we should be glorious. All right, so spark your learning. Viola is helping to plant a rectangular community garden. A plant handbook states that one plant requires 8 square inches of soil. Given the dimensions of the rectangular garden shown, how many plants can be planted in the garden? So there are obviously more than one way to solve this problem, but I'm going to do it this way. When I see square inches, I automatically think of area, and so I'm thinking about a garden and filling it with plants, so that is also area. All right, so our garden is 84 by 24. So to find the area, we're going to multiply those, length times width. 84 times 24. And I got that it's 2016. So that's our entire garden area. From there, I know that each plant needs 8 square inches. So this is the total square inches. So if I take the total square inches and I divide it by 8, I get 252. That means that if I take the whole garden divided by how much space one plant needs, I can have 252 plants. So that was the way I solved it. Hopefully you saw some other ways on the PowerPoint where you put your picture. So let's jump into our lesson. So vocabulary for today is algebraic expression is an expression that contains one or more variables. A variable is a letter or a symbol used to represent one or more unknown quantities. A constant is the specific number whose value does not change. And then a coefficient is the number that is multiplied by the variable in the algebraic expression. So in the example, we have 2x plus 75. Okay, that's what they gave us. Well, then they said, all right, we said, okay, well, 2 is our coefficient, so there's our coefficient. The coefficient simply sits in front of the variable, and it's being multiplied. So even though it just looks like 2x, in our head, we're thinking 2 times x, okay? All right, and then the 75 is the constant. Constants are usually easy to pick out because they're just a number all by themselves. Because 75 is constant. It's never changing. It's going to be 75 no matter what. All right, so that's kind of the thing. Whereas a variable varies or changes. We don't know its value right now, but it could be many different things. Okay? All right, so first problem here says a daycare center has 2 baskets of dolls. One basket has 8 dolls and the other basket has an unknown number of dolls in it. What expression can you use to represent the situation? Okay, so first we know that we cannot write a numerical expression here because of the unknown. When it says unknown number, well, we can't put a number to that. We can't guess. We don't know. So it cannot be a numerical expression. It has to be an algebraic expression. We know that there are 2 baskets. One has 8 dolls. And one has, we don't know how many dolls. That unknown number, right? All right, so then if we're going to write an expression for that, we could say, okay, well, we are trying to find the total. So total is addition. We know 8, but this question mark. Now that we're going to start algebra, we don't have to use question marks anymore. We're going to use variables. And I'm going to go ahead and use the D variable. You can use any letter you want, a D for doll here. Okay, I would maybe stay away from using the letter T because a T and a plus sign are very, very similar. Okay, all right, so this is our expression, 8 plus D. That's our first algebraic expression. We don't know how many dolls are in the second basket, but we know there's 2 baskets and one of them has 8 in it. It's as easy as that, guys. Now I do want to ask you one thing. what is the coefficient for this D? What number is in front of it? Not a trick question. The coefficient is simply a 1. There's only one D there. And we don't have to write the number 1, but we could, because 1 times D is still D, right? Because 1 times anything is itself. Okay, so anytime it might ask you what the coefficient is and there's nothing there, it's a little 1. All right, let's do one more here. All right, apples. Here we go. Kirsten works at a supermarket. She wants to divide a box of apples equally among 3 displays. All right, so we know that she has F apples, and she's sharing them in the 3 displays. Okay, so that's kind of what they're doing with their bar diagram there. And there's going to be apples here, and apples here. But we don't know how many apples are going to be in each one of those. But we do because we are super smart 6th graders. If we're going to take the apples and we're sharing them, that would be division. So we're going to divide them with how many displays? 3. So we're going to take F apples and divide them by 3. And a more algebraic way to write that would be F divided by 3 because we know fractions are division. We wrote another algebraic expression. That's it, guys. We took the apples, no idea how many, and we divided them by 3. Let's do the check your understanding. I want you to look at it. Number 1, it says, Raj is 3 inches taller than Howard. Let H represent Howard's height. Write an algebraic expression to represent Raj's height. Go ahead and pause and do this on your paper, and then press play when you want to go over it. All right, so Raj is 3 inches taller than Howard. 3 inches taller, so he is bigger, so we had to add 3. How tall is Howard? We don't know. He's just H. Okay, so that was the first one. Go ahead and pause and work out number 2. Marcus has 4 times the sum of 6 and the number of marbles David has. Let D represent the number of marbles David has. All right, so I like to just break this up. And if this were possible, I would write all over my words, but we all know it's just on the screen. So 4 times. So 4 times. Then I read that it says the sum. Anytime I read words like that, like the sum or the difference, I'm going to put parentheses so that I can add my sum in there, because that means that they want the sum first. So they're going to find the sum of 6 and the number of marbles David has. So 6 and the number of marbles David has. The sum is addition and David is D. Okay, so what that means is we had to do this first before we multiply. So this is completely correct, but a more algebraic way to write it is to actually just say 4 parentheses 6 plus D. So you don't need that multiplication sign. In algebra, if something is touching, then they know that that's multiplication. As long as it's a number and a parenthesis or a number and a variable, we assume that it is multiplication. It is addition, so you could do D plus 6 if you would rather. That doesn't matter. All right, go ahead and try number 3 now. All right, so number 3 says the quotient of T and 13. Quotient means to divide, and it says T and 13. Look at them using that letter I told you not to use. Yeah, T divided by 13. So it has to go in the order that it gives it to you. It says T and 13. The order of division matters. Try number 4 on your own. All right, so it says the product of G and 2 plus M. Product of G and 2 plus M. So the product of G and 2, let's see, G and 2, product means multiply, plus M. Now, technically, this is correct. However, again, we want to practice good algebra, so we don't want to do G times 2. We want to do 2 times G plus M. Put that coefficient in front of your variable. Remember, then you don't even need the multiplication sign. Just 2G can become a coefficient. All right, so now, hopefully you have some good examples written on your paper. I want you to go to the next thing on Canvas, and it will be a practice on your own on HMH. See you later.